Let's chem it up, people, and work on this Unit 3B THQ. Alrighty, here we go. We are going to start with number 1 and calculate the percent composition of oxygen in oxycodone. Oxycodone has 18 carbons, 21 hydrogens, 1 nitrogen, and 4 oxygens. So I need to add these all together to find the formula mass of oxycodone. I'm going to take 18 and multiply it by that mass of carbon, which is 12.01. I am then going to go in, plop it into my calculator, and what I find out is 18 times 12.01 equals 216.18. Now I'm going to go in and I'm going to take my 21 hydrogens. I'm going to take that 21 of those hydrogens. I'm going to multiply it by the atomic mass of hydrogen, which is 1.008. That's going to equal 21.168. I'll worry about all my decimals at the end. I then have 1 nitrogen. Well, 1 nitrogen is just the atomic mass of nitrogen, which is 14.01. So I'm going to slide that over to the other side too, so I don't forget to add it. And finally, I need to go with my 4 oxygens, which is 4 times 16.00. 4 times 16, as we all know, is 64.00. I'm then going to take 216.18, add to it 21.168, add to that 14.01, and then add that 64, and I get 315.36, rounding to 2 decimals because that's what sig figs tell me to do. I'm not done yet, though. I need to find the percent of oxygen. Percent of oxygen is the mass of all the oxygens, in this case 4 oxygens. And I'm going to take the mass 4 oxygens and I'm going to divide it by the entire mass, the formula mass of C18H21NO4. And then I'm going to multiply by 100 to put it in percent form. My percent of oxygen, I'm going to take this nice little mass of oxygen right here of the 4 oxygens at 64. I'm going to divide it by my mass of 315.36. And I'm going to multiply by 100. What you'll see is that I end up with 64 divided by 315.36 times 100. The question tells me to answer to 3 sig figs. To 3 sig figs, I get 20.3%. Alright, this should be a little review from Unit 3 that we did a couple of weeks ago. Or a little while ago, at least. And with that, I can move to number 2. Again, I'm doing a percent question, but this time I'm asking for the percent of water in a hydrate. So I gotta watch out for the little stupid dot formula here. My percent of water is going to equal the mass of all the waters, which in this case is 3 waters. And I gotta divide it by the mass of the entire thing. The mass of this entire thing is the mass of the NaC2H3O2, that sodium acetate there. That little dot means plus because it's stupid and not multiplication, so I gotta add the mass of 3 oxygens, or sorry, 3 waters, right there. So the mass of NaC2H3O2 plus the mass of 3 H2Os is on the denominator. Then I multiply by that hundo to get myself that percentage. Well, in order to do this, I need to find a mass of sodium acetate, NaC2H3O2. Alright, the mass of 3 waters is kind of easy, but we'll see that right here. So I'm going to slide on over. I have 1 Na, which is 22.99. I'm going to keep going to the side here because I'm going to have to do some multiplication. Got 2 carbons. 2 times 12.01. That gives me 24.02. I got 3 hydrogens. Just 3 times 1.008, giving me 3.024. I've got those 2 oxygens there, which is 2 times 16. 2 times 16, where I come from, is 32. But now I'm also going to add in these 3 waters. Don't forget those 3 waters are part of it. Each water's 18.02. I know that because I wrote it on my periodic table. 3 times 18.02 is 54.06. So I'm going to take 54.06 plus 32 plus 3.024 plus 24.02 plus 22.99, and so my entire denominator here, my formula mass of this entire hydrate, stupid dot and all, 136.09. I then need to take this 136.09, and it's going to stick with me for some crazy reason here. And it is what's going to go on the bottom here. The 136.09 goes on the bottom. Those 3 waters I came up with were 54.06 times 100. So my percent of water, 54.06 divided by 136.09 times 100, I get 39.7%. And that ends up being my answer for my percentage of water in that hydrate. Now, because that 136.09 wants to keep following me around, I'm going to have to erase it. And I'm going to move on to this next question. In this next question, we're looking at octane. Octane has a percent composition of 84.12% carbon and 15.88% hydrogen. I have to find the empirical formula. This is kind of what we did in the last few classes, right before the end of this unit. Remember, these percents, I can get rid of the percent sign and plop in little g's for grams. So essentially I have 84.12 grams of carbon and 15.88 grams of hydrogen. Now I have to go in, I have to convert my grams to moles. Well, mole conversions should be pretty easy now. 1 mole of carbon is 12.01 grams of carbon. 84.12 divided by 12.01 gives me, 7.00 moles of carbon. I now need to do the same thing with my hydrogens. I convert my 15.88 grams of hydrogen into moles. 1 mole of hydrogen is 1.008 grams. Because I'm just using that formula mass or that atomic mass of hydrogen. 15.88 divided by 1.008 is 15.8. Let's say 15.8 moles of hydrogen. But I'm not done. Now I have to divide these mole amounts by the lower mole amount. What is lower, 7 or 15.8? Well, of course, 7.00 moles is smaller than 15.88. So I end up with 1 carbon, because I need to get a whole number ratio. 15.8 divided by 7.00 moles gives me 15.8 divided by 7.00 gives me 2.25. 2.25 hydrogens. Well, 2.25 is a magic number. All right, it's too big to round, so I got to get it to a whole number. Well, what's 0.25 to a whole number? Well, it's multiplying it by 4. So I'm going to multiply 2.25 times 4. That gives me 9 hydrogens. But whatever I do to one part of the ratio, I have to do to the other. That was the ugliest 4 I've ever written. This one's not terribly better. 1 carbon times 4 gives me 4 carbons. So my empirical formula ends up being C4H9. That's my formula in lowest terms. Well, it's a good thing I have that formula in no lowest terms, because now I have to find the empirical mass. The empirical mass, relatively easy to find. I take 4 carbons, because there's 4 carbons in my empirical formula, and 9 hydrogens, because there's 9 hydrogens in my empirical formula. Let's go back and write something that looks like a 9 and not a little tree. That's better. 4 carbons plus 9 hydrogens. The 4 carbons is 4 times the mass of carbon, which is 12.01. 4 times 12.01 is 48. Me and numbers today aren't working too well. 48.04. 9 times 1.008 will get me the hydrogens. It gives me 9.072. 48.04, 9.072. Remember, I got to round to two decimal places here. I get 57.11 is my empirical mass. All right, if you haven't read ahead, I wonder if you can figure out what's coming next. I now have an empirical mass and a formula mass. The formula mass of octane is 114.224 grams. Using the information from parts A and B, find the molecular formula. So this is where I go in, I take that formula mass, I could call this a molecular mass, I could call this a molar mass, they're all the same thing. And I divide it by my empirical mass. Formula mass, 114.224. I guess I can bring the grams, because technically that's the unit of my empirical mass too. divide it by 57.11 grams. I'm going to round this to a whole number. 114.224 divided by 57.11 is 2. I'm going to take that 2 and multiply it by my empirical formula. Distribute the 2. The 2 times the 4 gives me C8. The 2 times the 9 gives me H18. And that, right there, is the molecular formula of octane. All right, there's only 2 questions left on this THQ. Let's mosey on over. All right, what we are starting with here on number 4 is a fungicide, something to kill fungus, like athlete's foot or jock itch, called Hexa Chlorobenze. Has a chemical composition of 25.3% carbon, so let's change that percent to grams. 74.7% chloride, we'll change that to grams too. So I have 25.3 grams of carbon and 74.7 grams of chlorine. Using the information, I have to find an empirical formula. So first thing I got to do is I need to go in, I got to take these grams of carbon, I got to convert it to moles of carbon. I do that by multiplying it by 1 mole over the atomic mass of carbon. The atomic mass of carbon that I'm multiplying it, or I'm dividing by, is 12.01. My grams cancel out, I'm left with moles of carbon. 25.3 divided by 12.01 gives me 2.11 moles of carbon. Now I need to do the same thing to my chlorine. 1 mole of chlorine is equal to the atomic mass of chlorine. I gotta look up the atomic mass. It's 35.45 grams. The grams cancel. I take 74.7. I divide it by 35.45. And I get 2.11 moles of chlorine. The next step is to go in and divide each of these by the smaller mole amount. Well, it's the same number, so there is no smaller mole amount. I divide them both by 2.11. And I get 1 carbon for every 1 chlorine. So all in all, here I have 1 carbon and 1 chlorine. I get CCl, and that is my empirical formula. I do not need to go further. Number 5 here, a student's performing a laboratory experiment of magnesium chloride. I'm taking that 46.83%, changing it to grams for the MgCl2. The 53.17% of water goes to 53.17 grams of water. And this is a lot like the last question. I need to convert these grams into moles. Well, to do that, I'm going to need a formula mass. Formula mass for MgCl2, well, magnesium is 24.31. Each Cl is 35.45. Yeah, I could multiply it by 2, or I could just add 35.45 twice like I'm doing it here, because #math. Oh, 5 plus 5 plus 1 is 11, and then we're going to carry the 1. Oh, let's just say 24.31 plus 35.45 plus 35.45 gives us 95.21. There we go. See, I told you it would end on 1. Now I'm going to go back. I'm going to take that magnesium chloride, that MgCl2. I'm going to put it over 1. I'm going to multiply it by 1 mole. Eventually, I'm going to multiply it. Here it is. There's that 95.21. That's the formula mass of magnesium chloride. That gets my grams to cancel. That's how many grams are in a mole. 46.83 divided by 95.21 is 0.492. And I'm sure I will catch up with myself. If you haven't been able to tell, I wrote everything and now I'm talking over it. I haven't done that for the whole video. We'll see if you can figure out where I did that and where I didn't. And there's my 4.9 or my 0.492 moles of MgCl2 as I run out of space. Now I got to do the same thing for the water. I plop the grams of water over 1. Now I multiply it. I put the formula mass of water, 18.02 grams on the bottom. I know that because I wrote it on my periodic table. 18.02 grams of 1 mole. Take 53.17, divide it by 18.02. And I get I get 2.95 moles of water. Now I divide by the moles of not water, which also happens to be the lowest mole amount. 0.492 divided by 0.492 is going to give me 1 MgCl2. I also have to divide the moles of water by 0.492. So 2.95 divided by 0.492, that is going to give me 6 H2Os. I have one last little step here. I got to plop this into stupid dot notation. So I write MgCl2 because there's only one of them. Then I draw in a stupid dot and 6 H2Os. And now I have a hydrate formula. And I have completed this THQ. I know I wasn't here for you guys to ask the questions, or you're watching this later. If a question arises as you're watching this later or while I was not in class, please feel free to send me a Schoology message or an email, or come see me the day of the test before the test, like before homeroom. I'll be in school about 7:40, 7:45 at the latest. Your class might be after Flex. You can come in at Flex. Your class might be after the recess at the end of the day, so you could always come in then as well. But that is it. You've been chemified. I'll talk to you later.